Alright, today we're going to continue with a discussion on least common multiple. We'll review how to do it with integers and then go to algebraic expressions. Another paper slide video. And again, like greatest common factor or least common multiple gets read backwards. It's a multiple that's common and it's the smallest one that's common. Least common multiple. And again, multiple being the key word here. So when I think of, say, three integers, 4, 5, and 8, what is the smallest number that they are divisible by? All three are divisible by. Well, again, it has to be a multiple, so it has to be, since 4 goes into 8, that's great. 8 could be the least common multiple, but 5 doesn't go into 8. So it has to be bigger than 8, because we are thinking multiples, and the smallest multiple of 8 is 8. If we look here, I could just list them out, but that would take a long time, because we start thinking about it. So a lot of students say, oh, well, how about we just multiply 4, 5, and 8 together? And you know what? That's a multiple. And if you're doing fractions, that definitely will work. But again, often that causes a number to be big. So again, there has to be a number in here that works. Okay? Often. And in this case, there is a number somewhere along the line. And I'm not going to list it out. I'm going to discover the least common multiple by thinking about it in terms of its primes. Now, when I think about primes, first thing I'll do is I'll break 4 into 2 times 2, and I'll break 8 into 2 times 2 times 2. And I know the least common multiple has to be divisible by each of the three. So the LCM has to be divisible by 4, by 5, and by 8. And so in this case, I know the least common multiple is 40. And I know that because if I put 40 in here, it is the smallest number all three go into. But often, students have a hard time seeing how to get to this number, and often haven't been taught the way I'm going to show you. If I take three numbers, 8, 15, and 100, and again, using a factor tree or some method to break it into primes, I always know that the smallest number that these three can have as the least common multiple is 100, the biggest number of the three. And 100 divides 100, so boom, we're done. But 100 doesn't get divided by 15. Evenly, and 100 does not get divided by 8. So I just start with the next step I had written down. I start with 100. 2 squared, 5 squared. And I have 3 times 5 on the bottom. Well, what cancels? Well, the 5 cancels here, but the 3 doesn't. So we need a 3 as a factor. So I had 100 here, but I need 3 as a factor. So I take the 100 and I put in the 3. Now I check it against the other number, which was 8. 2 cubed. Well, 2 of the 2's cancel, but I still have a 2 on the bottom. So if I'm going to get it to cancel, I need another 2 on the top. So this original number gets another 2, becomes 2 cubed times 3 times 5, or 600. Now again, I know students all the time have this shortcut. They say, oh, 2 cubed, because there's 2 squared and 2 cubed, I need the biggest one. Least is the biggest. 3 and we need a 5 squared. Okay, and I forgot to write the square. I know I included it, but it had to be 5 squared on both of these. Well, what about the next? Let's try another example. And again, maybe you want to cover this for an instant. I'll use my big old hand. And I got 30, 75, and 80. And again, if you want, pause it, because I'm going to pick up my hand. I already showed the answer there, I guess, by not covering it with my hand. Again, 80 is divisible by 80. 80 is not divisible by 75. And then 80 is not divisible by 30. Alright? So when I look at this, I start with 80. And I put 80 on top, and I divide it by 75. Well, one of the 5 cancels, but it leaves a 3 and a 5. So I need both of those factors. So I include the 80 and the 3 and the 5. And again, that puts 2 to the 4 still. It's the same. 3 is inserted. It was 1 5. Now it's 2 5s. And I check it against 30. 2, 3, and 5. Well, guess what? They all cancel. So that is the least common multiple already. It says got them. Alright, we got them. And if you take 2 to the 4th times 3 times 5 squared, you get 1200. Now, this time I'm going to make sure I use a piece of paper here, and I'm going to cover what's going on. Because on the next problem, I go from numbers to algebraic expressions. and it doesn't change. I have 15a squared b and 10ab cubed. And you'll notice the first thing I do up here is I break them down into their factors. And I actually break the a cubed and a squared into AA and the b cubed into BBB. And again, the same method. I know that 15a squared b is the biggest one of these two, and I'll use the one with the biggest number. And I know that 10a b cubed does not divide it divisibly evenly into 15a squared b. And so I will just take it and check. I'll write it out, and I'll see that when I get done canceling, on the bottom there's 2bb still. I cancel the 5s, I cancel the a's, I cancel one of the 3 b's, but I'm left with a 2bb. I have to combine the 2bb and the original 15a squared b. When I do that, I get 2 times 3 times 5, AA BBB, or 30a squared b cubed. And again, the least common multiple of 15 and 30, 15, 30, these are the first two multiples of 15, 10, 20, 30, third multiple of 10, that's the least common multiple for the numbers. A squared and A, well, A squared is the least common, B and B cubed, B cubed. Finally, the last one I have here today is 12xa m squared and 14x cubed a m to the fourth. And this time, instead of breaking xx and mm, I left them as x squared am squared and x cubed am to the fourth. I just wrote the primes. And I go, again, I know the second term is divisible by itself, so the larger term is divisible by itself. So I'll just check 14x cubed am to the fourth divided by 12x squared am squared. And I do that here on the left, right here by my finger. 2 times 7, x cubed am to the fourth, over 223 x squared am squared. When I do the cancellation, because it's one factor on top and bottom, I'm left with 2 and 3 on the bottom. So I need 6. 2 and 3. I'll leave it as 2 and 3, but 2 times 3 is 6. So I had 2, and I had this 2. Now I have 6 here, and there's the 7. And I had all the variables. When I multiply those 4 primes, I get 84 x cubed am squared to the fourth. Not easy. Least common multiple takes some practice. It's very easy to confuse with greatest common factor. Remember, the word multiple means bigger. Factor means it has to be smaller. It takes practice.